Okay, so in this demonstration we're going to have a look at the inverse normal, and you can see we've got some orange juice. It's got a mean of 250, so let's get this down into some mathematical language. We normally distribute it with a mean of 250 and a standard deviation of 5, so a variance of 5 squared, and we know that the probability that x is less than some value, let's call that m, for the minimum value is %, which is 0.05. Okay, so those are the sort of 2 bits we can glean from there. And as I asked you to draw a picture of that, maybe a better picture than that, of course, but make it some sort of normal shape. This is the x distribution, and we know the mean is 250. And somewhere down in this left corner, there's such a thing as a corner down there, we have a value, an area of 0.05. This will translate into our Z standard normal with a mean of 0, but still obviously we'll have we're looking for the area of 0.05 in there. The task then is to find what value on that x-axis there, what value that is. And once we've got that, we can use it. So, probability x less than the minimum value is 0.05. Looks like this. So it's going to be x is less than m minus 250 over 5. And that value has to be 0.05. So we've been given the answer, if you like, of 0.05, so we have to look in the tables. And you'll notice straight away in the tables there is no 0.05. So look at the symmetry of the graph. I'll show that up here. What we're saying then is the black area that is marked would be the same as the white area. No, let me colour it into red. This red area here would be the same. So now what we have is, this is still the Z distribution. So that little red area is 0.05. And our tables will be able to give us this value here, right there. Okay, so if we look at a 0.95 instead of 0.05, you'll see on your tables that that gives a value of 1.6449. So we've got 1.6449 from the table. Tables. Got. Okay, so on our little drawing up the top, this is 1.6449. So again, by symmetry, if that's 1.6449, when we flip it over, this must be, looking at this diagram, negative 1.6449, because again, just looking at that symmetry. So going back to the calculation, negative 1.6449 is going to be less than m minus 250 over 5. Now if we rearrange that, then we've got 5 lots of negative 1.6449 added to 250. Okay. Is less than m, which gives a value of m being bigger than 241.7755. So the question asks us for the nearest milliliter. So the minimum value m must be 242 milliliters. And that's it. Finished.